Okay, guys, we are going to take a look at our scale drawing day, lesson 2. All right, and tomorrow we're going to throw you for a little bit of a loop. It's a very mathematical loop that makes total sense, but it's really important that we nail down today's lesson. So let's take a look at the explore that we did. And so I'm going to read here. So our framing is how can we use a scale drawing to compute actual areas, which we did a lot of today. Okay. So the diagram below shows a scale drawing of a floor of a rectangular living room. The diagram uses a scale of 1 inch is equal to 4 feet. What is the area of the actual living room floor? Okay. So this is my key information box here. I have my scale, which is that 1 inch is equal to 4 feet. Okay, super important that I put those units there. I know that my width is 8 inches and my length is 3 inches. Now I've heard the question, wait a minute, how do I know which one is the length and the width? I thought the length was the longer one. The truth is it does not actually matter because when I'm calculating perimeter or area, I have the commutative properties of addition and multiplication, meaning 8 times 3 is the same as 3 times 8. So it does not matter what I put as my width or my length. When we get into a little bit of later geometry where we're talking about finding surface areas of three-dimensional shapes, it might become a little bit more important, but at this point, it's not something that we need to worry about. So I know that my scale is here. This is my scale. 1 inch is equal to 4 feet. Okay, and just as a reminder, that means that if it's an inch here, that it's 4 feet in real life. And then I have my width and my length. I need to find the area of the actual living room floor, okay? In order to do that, I need to find the actual widths and lengths. Now, somebody said to me today, hey, Messiah, can I just do 8 times 3 is 32, or sorry, 8 times 3, 24, and then 24 times 4 for my area? And the answer to that is absolutely not, okay? And I'll show you why in a second. So I do need to find my actual width and my actual length, okay? So I'm gonna go here and I'm gonna do my actual over my scale, and then I'm gonna put my scale here. So 4 feet is equal to 1 inch, all right? And then I know, because this is my width that I'm gonna work on now. My width is gonna be W, because I don't know the actual width, over 8 inches, okay? And so here I cross multiply. 1 times W is W, right? And then 4 times 8 is 32. So my width is equal to 32 inches. Now I want to find my length. I have the actual and I have the scale. And then I'm going to do it again. I'm going to put the scale 4 feet over 1 inch. And then I'm going to put my L over 3 inches. I want you to notice that my inches is in the denominator here. My inches is in the denominator here. Inches in the denominator here. Inches in the denominator here. Feet in the numerator, this is going to be feet. Feet in the numerator, and my width is also, oops, silly mistake, Miss Syed. My width is also in feet. Okay. It's important that that you remain consistent across the numerators and the denominators. So my length here, again, I'll cross multiply. 1L 4 times 3 is 12. My length here is 12 feet. And now I have all the tools I need to find my area. My area is equal to length times width. So my area here is going to be equal to 12 times 32. And when I do that calculation, my area is equal to 384 feet squared. Now, going back to my question up here, hey, Messiah, why can't I just do 8 times 3 is 24 and then multiply that by 4? Well, if I were to have multiplied 24 by 4, I would have gotten 96. All right, and that is absolutely wrong. And we'll talk more tomorrow about why that is. But for right now, for today's lesson, it is critical that you understand you need to find either the actual or the scale, whatever you're being asked for, before you can find the area. All right, I'm going to move on. Okay, and I want to take a look at, because the exit ticket got a little messed up, I'm going to do the exit ticket, and then we'll do a little bit of the homework. Moving on down. Okay, exit ticket. And I know we set up some work for this today. So I have Benji, he's my architect, and he designed a house and drew a blueprint to show his client. The scale of his blueprint is 1 inch is equal to 4 feet. One of the bedrooms on the blueprint is a rectangle measuring 3 inches by 4.5 inches. What is the area of that bedroom in real life? This is actual. And then I'm looking for the area. All right, show your work. So again, my key information box here. I have my scale. 1 inch is equal to 4 feet. I know that my blueprint is 3 inches by 4. I'm going to change it to 4.5 because I prefer working with 4.5. 3 inches by 4.5 inches, okay? And I need the area of the actual. All right, so first, just like I did with the last problem, I'm going to find, and let me move down here just a little bit so I have room to work. Okay, first I'm going to find my width. All right, so my width here, I'm going to go actual over scale is equal to 4 feet over 1 inch, right, because that's my scale, equals, and then we'll say W, because I don't know my width, over 3 inches. Again, notice how my feet line up and my inches line up. And I can go here and cross multiply, and I'll be left with 1W is equal to 3 times 4. So my width here is equal to 3 times 4, which is 12 feet. All right, and this time I didn't make that same silly mistake. All right, so now I'm going to find my length. So I'll put my actual over scale. Yes, Miss Syed, every single time you make me do this. 4 feet over 1 inch is equal to length over 4.5 inches. Okay, again, I'm going to cross multiply, and I'm going to do 4 times 4.5. Okay, and that gives me 18. So my actual length, my length is equal to 18 feet. Okay, so now I have what I need to find my actual size. So I'm going to go 12. So area is equal to length times width. We know that. So area is equal to 12 times 18, which means that the area here, 18 times 12, is 216. So I have an area of 216 feet, and it's an area, so it's squared. Okay? So that's our exit ticket. We'll do a couple of homework problems. Oh, you know what? I was showing this off to somebody earlier, so that's why it has all this weird stuff. Erase that. Okay, cool. And we'll go with red. A thumbnail picture is 1.5 inches wide and 3 inches long. And 3 inches long. Using a scale factor of 1 inch for every 15 feet, what will be the area of the enlarged picture? Okay, area. So I'm looking for the actual. This is my sort of scale. All right. And so my scale factor is 1 inch for every 15 feet. Well, this is going from a thumbnail picture to a giant poster, apparently. Billboard even. All right, cool. Key information box. All right, I have 1.5 inches is equal to, oh, whoops. Sorry, Miss Syed got a little. 1 inch is equal to 15 feet. All right, and then I have my 1.5 inches by 3 inches of my thumbnail, and I need to find the area of the actual. So I'm going to first go with my width. All right, so I'm going to put A over S. That's my actual over scale. All right, instead of writing out the words, you can see, you'll know what that means. So my actual is 15 feet over 1 inch. I'm just putting my scale there. All right, and then my actual width is W over 1.5 inches. All right, so I have 1W, and then I have 15 times 1.5. And that's going to give me 22.5. So my width is equal to 22.5 feet. Okay. All right, now I'll find my length. So I'll put actual over scale is equal to 15 feet over 1 inch, which is equal to length over 3. Cross multiply here, so length is equal, L equals 15 times 3, so my length is equal to 45 feet. And then I do area. Area equals length times width, meaning area is equal to 22.5 times 45. Okay, and when I do that, I am going to get 1,012 and 5/10 square feet. 1012.5 feet squared. And looky here, that is absolutely a possibility. Okay. Now, if I had done, okay, well then what's 1.5 times 3? I would have gotten 4.5, right? So this is sort of the tricky, close confuser here. All right, so I will do one of these weird scale ones here. So we'll do the Empire State Building one, because the way they give us the scale here is a little bit different. The floor plan of the Empire State Building is drawn with a scale of 60 to 1. What does that mean? That means for every 1 unit of measurement on the drawing, the actual is 60 times larger. So it says here the length of the entrance wall is 15 inches and the side of the wall is 20 inches. And I don't love the wording of this, but they're talking about the floor plan here, okay? What is the area of the base? Is the area of the base. And again, I don't like the wording here. I'm there meaning the actual base. What is the area of the actual base of the Empire State Building? I think. Let me make sure I'm right about that. Yeah. Okay. Cool. So, boom. My scale here, 60 to 1. So I'm working with inches. Okay. So my KIB over here is going to say that 1 inch is equal to 60 inches. And that's sort of, it's 1 inch to 60 inches. I'm going to draw that like a ratio instead. So this is my scale and this is my actual. All right. And then I have my drawing here is 15 by 20. So I'm going to find the width first. So I'll do actual over scale. And I just have the double U here to know that that's what I'm doing, is equal to, okay, actual is 60 inches over 1 inch, which is equal to the actual is W over 15. All right, so I'm going to have to do 60 times 15 to find out the actual width, and I get 900 inches. For my length, I'm going to put my actual over my scale equals 60 inches over 1 inch equals L over 20. Cross multiply. 60 times 20 is going to give me 1,200 inches. So my length is equal to 1,200 inches. All right. So using area is equal to length times width. I'm going to go area is equal to 900 times 1,200. And I get 1,080,000 square feet. My area is equal to 1,080,000 feet squared. Okay. So, oh, see that 0 disappeared. So my answer here is D. All right, guys. That's it for today. I really want you to take the time to write those ratios, to write your units every single time, even though it seems like a lot of work, even though you could just look at it and go, oh, okay, it's 15 times 60. It's important that we write this because when it becomes more difficult, you're going to want to have this good habit. I hope you guys have a great night and we will see you tomorrow.